Awesome. Well, thanks everybody for joining us. We're really excited to show you our latest linear lessons for math. We have the Ozobot team members here that actually created the lessons, and I'm going to walk you through each one. We've been releasing learning more lessons for kind of all the lessons that we're creating in that series. You can access those on our PD page. You can register for upcoming ones, look at our past ones. It's all there as a resource for you. As Melissa said, my name is Anthony. I'm the Ozobot account executive supporting New York, New Jersey, and a few states across the United States. Been lucky enough to be part of the Ozobot team since 2015. Was actually on our social media team. I didn't realize Twitter was such a popular platform for y'all, but it was a fun time engaging and seeing all the fun and creative ways y'all were using Ozobot in the classroom. Now I'm an account executive. It's fun to, you kind of saw it from afar, but now I get to be part of the initiatives that you are working on, and just really collaborating with educators and being part of that environment. It's just been a lot of fun being innovative in the program. So we'll jump into some housekeeping items. Just so you're all aware, everyone is on mute and your camera's off, so you don't have to worry about that. Nobody is watching you, but hopefully you're somewhat dressed like your students are, like they're supposed to be. But we'd love for everybody to join the conversation. We do have the Q&A, so if you have any questions, pop those in there. Feel free to upvote those if you think you have a similar question, or comment on those if you have your own insights. We'd love to see those in the chat. Would love for everybody to kind of start a dialogue there as well. Melissa also mentioned just making sure you select all panelists and attendees. That just makes sure everybody sees that. And team members from the Ozobot will also be monitoring that. So we'll be there to support as well and provide insights. Very common question. We will be recording the webinar. The slides will be accessible after. I can access that on the email. Via email, we'll follow up with that. If you opted in for that, accessible via the YouTube page and on the webinar page as well, like I mentioned earlier. Awesome. So we already did housekeeping. We'll jump into our 2 ways to code. It looks like everybody was actually already pretty familiar with Ozobot, so we might kind of glance over that. Melissa will share our Learn Anywhere lessons and provide an overview so you kind of understand the anatomy of what actually is a Learn Anywhere lesson. And then I believe it's Natalie and Jen will be going over our actual math lessons for grades 2nd through 5th for week 5. You'll get to see me again, yay! Going over, you know, it's been unprecedented times, and we've tried to adapt to make sure everything we're doing supports what y'all are trying to do in the classroom. So we'll go over the one-to-one program, have time for Q&A, and then we'll finish up with that giveaway. So the 2 ways to code, we have quite a few Ozobot users. So if you know the 2 ways to code, would love to see you put it in the chat. We didn't actually label them here, but the first way is screen free with colors. It's our patented method using markers and paper. And I'll go ahead and say it. It's the color codes. It's what we're most known for, super popular for it. It's just a nice, easy floor to get students into it. And then Ozoblockly is kind of our high ceiling where students start to scale things. And it's powered by Google. It's our Ozoblockly visual programming editor. We have 5 skill levels. Level 1 is pre-reader, so students don't have to go to read to start programming with Evo. And then it goes all the way to level 5, where it gets pretty advanced with math, variables, functions, arrays, lists, things that smarter people know how to use than me. But there's a lot of great tools here to help you if you're not familiar with those to get started. Awesome. And this is the other Ozobot team members on here with me from the EDU team with Jen, Melissa, Natalie. I'll popcorn to Jen to introduce yourself. And you are muted. It wouldn't be a Zoom meeting without somebody talking while they're muted.
That would be me. Hopefully my internet will work tonight, so we're good. My name is Jen Maher. I am with the customer experience team at Ozobot. I also am doing some curriculum development and creating some super fun lessons, I hope, for your students. And I'm a former teacher, spent many years in the classroom as a dance teacher, and the last few years as a math and science teacher. And I have a master's degree in curriculum and instruction. And I will popcorn to Melissa.
Hi, everyone. My name is Melissa Tui. I am also a former teacher, and I'm the Ed Tech and Adoption Specialist here at Ozobot. Taught kindergarten and first grade in the past, founded a coding, engineering, and design thinking program in South LA, and love all things computer science. So I'm really excited to be here with you all. And I'll popcorn over to Natalie.
Jen, I followed suit. Anyways, hello, everyone. Happy to have you all here with us this afternoon or this evening, depending on where you are. Similar to Jen and Melissa, background experience is in education, like many of you, spent multiple years in the elementary classroom, and then transitioned into instructional coaching, specifically computer science immersion, and onto development. So hopefully, as Jen mentioned, we are trying to create some multiple purposeful and in-depth meaning lessons for your students to hit the content aspects of what needs to be taught objectively, as well as those computer science standards. But most importantly, hopefully they're fun and engaging. And I think back to you, Anthony.
Sure, I'll take it. I already introduced myself. I don't know, in our general PDs, we say our favorite food, so I'll add that. My favorite food is, I'm vegetarian, so like a, a vegan orange chicken from Trader Joe's.
Yum. I'll have to check that out at Trader Joe's. I didn't know they made that.
Yeah. But I'll pass it to you since you're already talking, go over learning more lessons.
All right, thanks, Anthony. So I know some of you have been in these webinars before, but if not, we're just going to quickly go over what each lesson package entails. We've covered this in the past as well, so if there's any content area or lessons that interest you, feel free to check out that past webinars page that Anthony mentioned. But the content we are developing currently is 2nd through 5th grade lessons, and we recommend a pacing of 1 lesson per week. And these activities are about 45 minutes long, just depending on your students' ability levels and their skill levels. And all of these lessons are content aligned with at least 1 ISTE standard, 1 CSTA standard, and 1 content standard. Every single lesson comes with a synchronous lesson plan. It comes with an instructional video that is student facing, but if you're a teacher, you know teachers that may not be as confident in delivering computer science instruction, you can absolutely use that video to help guide your instruction and be a system of support for you. We also include a student activity guide for any student that might need to access visually the directions of the lesson, but again, all of that's covered in the video. So unless it's a student with a special circumstance, it's not necessary, but we provide it anyway for you. We also include all the sheets and the potential solutions and answer keys in the lesson. And if these are videos that you've used before, we'd love to hear your feedback in the chat. If this is something you've used with your kids, if they like them, please let us know, because we're always looking to improve and we want to support you in the best way possible. Something I do want to share really quickly is that in Ozobot Classroom, to find these remote-friendly lessons, you'll create a free account for Ozobot Classroom. Then on the left-hand panel, if you click on lessons, you'll be able to find all of the lessons in our lesson library. These are user-generated lessons along with internally developed Ozobot lessons. And to find the lessons that have these videos that go along with it, you can see that there's a remote-friendly icon here. That means this lesson package comes with everything that I just described. You can see in this lesson, this was a user-generated lesson, so there's no video in those materials. So that's an easy way to differentiate really easily what resources the lesson offers. There's also a remote-friendly filter here. So if you want to just see remote-friendly lessons that have video content to go with it, you can apply that, and then you'll be able to see all of that content there. So again, every lesson comes with a traditional synchronous lesson plan. This is just like what you would see out of a textbook. And those answer keys look something like this. So we are going, before we jump into the content that we wanted to share today, I do want to highly recommend that you start your students off with our first 4 introductory lessons. In Introduction to Ozobot Get to Know Evo, we talk about the hardware components of the bot. And then in the following 3 lessons, we actually onboard students to all of the color code capabilities. So once they're done with all of these 4 lessons, they're ready to jump into any of our content lessons. So we highly recommend that you begin there. And again, you can find all of these lessons in Ozobot Classroom. So we are going to cover 4 different lessons, math lessons today. So I will pass it to, I believe, I can't actually, is it Jen or Natalie that will be modeling for us first today?
It's me.
Okay, great. All right, I will stop my screen and pass it over to you.
Okay, and I'm going to share this lesson on my camera. So can you guys see can you see this part?
And just helpful hints, if I can share, Jen, for those in the audience, if they want a bigger view, they can click on the top right corner to view and go to full screen, and then I'll also select the speaker view, and that will get your screen full up so that they can see more, all the details of your screen.
Perfect, thank you. So in this particular lesson, what we're doing is we're working with money. So we have quarters, dimes, nickels, and pennies. So the bot is going to choose a coin, then it'll choose how many. The students will write those values and the quantities on this sheet. They'll add them all up and get a total. Then at the bottom of the sheet, they're actually going to put those quantities, those totals, in order from greatest to least. And then they get to put those on this sheet with a color code, and then they'll run their Ozobot over it to have a dance at the finish. So let's go through a couple of those things. First, I'm going to calibrate my bot because my lighting's changed since I last calibrated. Got the green light. So I'm simply just going to put that right on the start. Watch my bot go. It randomly chooses at intersections. So you never know where it's going to go. Watch it turn back down the start line. Of course it would turn down the start line. And number 6 may not be the one to use today. Oh, there it goes. Patience. So it chose nickels, and then it chose 7 nickels. So on this sheet, I'm going to find my nickels, and I'm going to write 7 nickels. Then I'm going to repeat that 3 times. So we have 3 different values there. Oh, I'm just going to choose more nickels. Oh, 7 more nickels. So then if that happens, you have 2 options. You can either start again or just add that number of nickels. So we're going to add 7 more. So we have 14 nickels. Oh. I'm going to laugh if it chooses nickels again. Pennies this time, and we have 8 pennies. So then we just write our 8 pennies here. So since this is a 2nd grade lesson, although you could use it in 3rd, 4th, 5th, even 6th grade if you wanted to, 2nd graders, they know how to count by 5s. So since they have nickels, they can count by 5 14 times. You can just use their fingers. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. So then they would come over here and put in 70 cents. And then they have 8 pennies. So that's going to be 8 cents. When you add 70 and 8, you get 78. And then they'll go through and they'll run their bot over the chooser 3 more times for each number. Yeah, so you'll have numbers over here on this side for each one of those 8 lines. They'll figure out the value of that number of coins, write it here, add it up and get a total. again, like I said, they'll take these total numbers, and you can even use the example too if you wanted to. There's not a line at the bottom for the example. And order those from greatest to least, and then assign a color code to each one. They get to choose whatever color code they want. So they can use the color code chart here. You can also find the color code chart in Ozobot Classroom over on the left-hand menu currently. And any 3-color code, they can put it in their Money Mountains map. There's 3 spaces for each color code. So any 3-color color code they can put in there. They'll want to be careful if they decide to choose a line switch code, because then it'll go from this line to another line. If they, in this space, if they put in a line switch left code, it's going to go off the page. So they'd want to be careful and put in a line switch right. Along with this lesson, though, there is a color code key, and I believe the color code key only has the speed codes on it. So you could use that as a resource as well if you wanted to kind of limit what their choices for the color codes there. So I already finished one up with some values that I made up. And so in the end, they just get to put their bot and watch it go. If you're printing in black and white, you can always have them put in that finish code at the end. That is a win, play again code, a win exit code, play again. So that's why it does that fun dance at the end. If it will go and do it again. And they can always just fill that in if you're printing in black and white again. Nice. If you have any questions about this lesson, you can throw them into the chat or into the Q&A, and we can answer them at the end. And at that, I'm going to pass it over to Natalie.
All righty, thank you, Jen. Oh, let me turn my background off so you can see my camera. All right, so second grade, we are moving on up to third grade, all about fractions, fun times. So for this particular lesson, we are looking at determining if a pair of fractions are equivalent or non-equivalent. So students are going to be using fraction models to identify equivalent, non-equivalent fractions, and then they're going to the outcome of the pair based on a set sequence of color. I know Jen mentioned all of our maps, for the most part, honestly, are black and white printer friendly. We've really tried to be more intentional about that. You will find, even though a lot of the codes and colors need to be filled in by students, if there is a color code key, that will be in color. But don't feel pressured to have to print that out in color. You'll notice that we include the exact color in our own little code language. So if this needs to be shared with students in black and white, it's totally fine. The G would be green, R would be red. You'll just explain that to your students. B is blue, and anywhere they see a BK, that's black. So don't feel like you necessarily need to print these activity sheets out in color. But for all of you, I wanted you to have top class, so I printed it in color. But we're going to look at the first pair of fractions, and you'll notice on the left side, the fraction model is drawn out for the students, and the initial fraction, numerator and denominator, or the name of the fraction, is complete. On the right side, the model is finished for the students. The denominator has been given, and students have to figure out the missing numerator. So for example, we have 1/2 on my left side for number 1, and we have something out of 4 on the right side. So the students would count the parts to determine that missing numerator. They're going to write it in, And then looking at the two fraction models, are these fractions equivalent, meaning equal, or are they non-equivalent, not equal? So as you all know, because you're smarties, these are equivalent. So I would put in my equal color code. So in the middle of this particular, these two particular models, I would put in the sequence green, red, green. And I'm also going to include a win play again to celebrate these fractions being equal. So I do want my bot to dance at the end of the line. And this might be a good lesson. Students definitely could do independently once you've taught equivalent and non-equivalent fractions. Or you could even utilize this to introduce the concept. But hopefully with the coding and all the visual extras, it'll help students retain the concept. So I'm also going to calibrate my bot because it turned off on me. I love index cards, and I just put a black calibration dot on it. It's a very efficient way for all your students to have their own calibration cards. So let me calibrate. Come on, you. Hopefully he's got some battery in him. I don't know about you all, but that gets me so pumped up every time. All right. So looking at this very first comparison, we know that they're equivalent. So we're going to watch our bot in action. And it's going to spin. Yay, they're equivalent. And celebrate. Okay. If I were to continue with this lesson, you'll notice that the activity, I zoomed in and now I wish I had zoomed out for y'all, but the activity has a total of 8 fractions that have already been inputted or are already done for your students as far as the fraction models go. There also is a blank template though, so you could determine your own fractions. You could even use something else besides fractions to compare, or you could have your students put their own fraction models in. But for this particular example, to just hand out and do, the students have 8 different fraction pairs that they will compare. So here's an example of, I think this was page 2, but just so you can see, so this was is an answer key, which you all have access to with all those lessons, but we had 1/3 compared to 2/8, and you can see that the bot is going to behave differently to show that these two fractions are not equivalent. And it shakes its head and you can't really hear it, but he's kind of disappointed at the end. So these two are not equivalent. So hopefully with that animation with the bot and those extra sound effects, it'll just help students retain and remember like, oh yeah, 1/3, 2/8, I know those two, they're not equivalent. And that is my, yeah, brief little example of equivalent fractions. So Melissa, I think Jen, we're moving on to 4th grade.
That is correct. We are going to do some division. Everyone's favorite thing to teach. Long division. Let me share my camera again. So in this lesson, my whole goal was to make sure that students were able to follow along with the steps of long division and race with their Ozobot so that they would have some motivation to continue going and not give up before they were finished. So we're going to do an example and then we'll do some racing. So you'll notice in this map, there's a color code right here at the beginning. That's for students to fill in if they are feeling not so confident. They would probably want to use the slow code because the whole idea is to finish the division problem before the Ozobot gets to the end. So they have to move pretty quickly to do that. So a slow code here might be for a student who's maybe struggling, but you may have some students who are just lickety-split quick, and they might be able to finish it with a turbo code there. So it provides a little bit of challenge. So
Jen,
along with
zoom in a little bit. Sorry, just so we can try and see a little bit better. Because I know this is a very amazing map, so I just want to make sure everyone can see all the parts to it.
Is that better? Can you see it better? Okay. So along with this lesson, there are 16 problems that come with the lesson. So let's go ahead and we'll do number 1. Number 1 is 34 divided by 2. So this lesson is color-coded. So fortunately or unfortunately, there are a lot of colors in this lesson. Underneath each line, though, is a letter that represents the color of the line. So if you needed to print it in black and white, you could still see most of the lines. There's supposed to be a yellow line here, which in black and white doesn't print very well. But if you have you can look up on your screen as you're printing and fill in the yellow lines so that students can find them, and then you can copy it again with a yellow line here, maybe. Might be an option if you can only print in black and white. But notice there are a lot of yellow lines. The yellow line represents the divisor of the problem. So in this particular problem, our divisor is 2, and our dividend is 34. So we're going to put the number in the tens place there and the number in the ones place there. So we have our original problem, 34 divided by 2. Now in the video, we ask students to fill in all of the yellow lines at the beginning. So before they start their bot or anything, half of the lines on the page are already filled in. So they'll fill in the 2 there. They'll fill in the 2 here. There's another yellow line. Here's another one. Here's another one. Did I miss any? I think that's all of them. So then you follow the Ozobot line around as you're doing the steps for division. So we're going to also take our red line, which is 3, and we're going to fill in the 3 on the red line. Then we're going to answer this question. 3 divided by 2 equals the orange line. Well, we can't do that evenly, so the most we can get out of that is 1. So we put our 1 on both of the orange lines. Then, as we follow the Ozobot line around, we have another orange line that will have a 1 in it. So then we have another question here. We have 1 multiplied by 2 equals 2. And that's on the green line. So we find the other green line and we fill in the 2. Then we come down around this way. We have our, what am I looking at? We have 3 minus 2 equals the brown line. We have 1. Then our brown, we have another brown line over here. So this is our 4th step in division. So we're checking to make sure that whatever we've just subtracted is less than our divisor. So we ask ourselves, is 1 less than 2? If it's not, we need to start again because we need a different number in our quotient here. But in this case, yes, it is. So we get to bring down the number in the ones place, which is on the blue line, which is 4. So now we're going to look for our other brown line and our other blue line, which are both here. So we fill those in with the same number that's corresponding. Then we have another question. 14 divided by 2 equals, and then we have a purple line, and that's 7. So we find our other purple line. We fill in our 7 on all the purple lines. And again, we're following the Ozobot line around. 7 multiplied by 2 equals 14. We find our other pink line, which is down here. Oh, but then we have our brown and blue lines again. So I didn't fill those in, and I probably should have. So then we're back at another checking place. So we come back over here. We have brown minus pink equals 0. So we put our 0 here. Is 0 equal to 0? The answer is yes. So you're finished. In this lesson, there are no remainders for any of the problems. They're all evenly divisible. There's another lesson actually as well that has all problems with remainders. So there's another step there where you put the remainder back up in your quotient. So then, now that you know how to use this, should we do one and see if I can beat it? Let's try it.
You got this.
I'm going to actually do a slow code because I'm a little intimidated. So I've got my slow code here. Okay, and I'm going to actually do the next problem on the page, which is 78 divided by 3. And then I'm going to fill in all of my yellow lines, which I know where they are just because I know where they are. Most of them anyway, probably. Let's see, we have a 3 here. We have a 3 here. We have a 3 here. And I think that's all of them. All right, here we go. Okay, so I'm following my words here. So I have 7 divided by 3 equals 2. And 2 times, 2 times 3 equals 6. So I have a 6, and then I have a 1 here, and 1 is less than 3, so I can bring down my 8. So then I have 18 here, and I have 18 here. 18 divided by 3 equals, I don't know if I'm going to make it, 6. 6 times 3 equals 18. 18 minus 18 equals 0. Is 0 equal to 0? Yes. Oh, and I forgot to put my win code in there. It's green, blue.
That was awesome, Jen.
Let's recreate. There we go. Whoop, wrong way. Oh, go that way. We'll see if it'll read that code since it was so crooked. Ta-da! Again, if you have any questions or comments about this lesson, please put them either in the Q&A or in the chat so we can answer your questions at the end. Thanks, and we're back over to Natalie for one more lesson.
You might be muted.
I am muted, and I was just saying, well done, Jen. If you want to test your math skills, you know, add some pressure. Not only did you have the bot to race against, but everyone was watching you do your math. That's like my biggest fear. People watching me, or adults, I should say, adults watching me do math. Children, it's different. But for 5th grade, we are working with ordered pairs for this next lesson. So students are getting familiar with a coordinate grid if they are not yet familiar with a coordinate grid, or reviewing the concept of a coordinate grid. And the whole focus is on how coordinate grids are used to determine the location of a point or an object. So students are given a blank template that is a coordinate grid. I know it's very hard for you all to see because the lines are very light, but there are boxes like a typical grid or graph paper. So the way the lesson is oriented is it has students first determining an ordered pair. So they do get a little bit of background as far as the function of the x-axis versus the function of the y-axis, how the two go together to make an ordered pair. And then they would choose their values. We do talk a little bit about introduction to the positive and the negative values as well. So again, this could be an intro to ordered pairs and coordinate grids for your students, or this could be utilized as a review and your students could absolutely do this on their own. So if I were to pick an ordered pair, let's see. Anthony, can you just give me a number, positive or negative, up to 7?
7.
Okay. Melissa, can you give me another number, positive or negative, up to 6?
3.
3. Okay. Perfect. All right. So my coordinates that I am going to plot or show the location of using my bot are going to be 7 and 3. So first, students are going to use boxes to kind of map out where the location of this ordered pair is. This particular lesson does not involve color code sequences. Instead, the students are utilizing different colors to represent values on the x-axis compared to values on the y-axis. So if I'm doing 7, let's see, I'm gonna do 1. It's hard for me to see these lines. Okay, 2, 3, 4, 5, 6. Oh, I ran off. See, I miscounted. 7, we'll make it work. Okay, so X value is 7, and then I'm going to go up 3 to show my Y value. I need better lighting. Okay, so now that I've mapped out where that coordinate is going to be located, using my ordered pair, I can use my color code markers. Students will choose one color to represent the value of the X and a different number to represent the value of the Y. So I'm just going to start by coloring in my boxes for my X. And then I will color my boxes for my Y. And then as we know, since our bot needs the line to follow, starting from that origin point that is marked for your students, I'm going to put in my black line. And you can have students complete as many of these as you would like to demonstrate multiple different ordered pairs. When they're ready to test their bot, they're going to run it from their origin. And you'll notice that my bot changes red on its LED light to represent the number value for my X and the number value for my Y. So to double check it, you can have students count the light changes to make sure that those values in their ordered pair are rightfully shown. Another option that I thought of, so 2 different ways to do this lesson. One is students determine the ordered pair first and then they demonstrate it with their bot. Or you could kind of flip the activity and have it be a challenge as to where's the location of your bot. So you could have students draw out an ordered pair and then have to determine the location to plug in the actual coordinates after. So for example, if we were to look at this sequence that was drawn, again, I'm going to start on the origin. We can count the light changes to determine where did the bot end up. So it changed colors 6 times on that x-axis. So I know that my ordered pair is a 6 for the x. And then it changed 3 colors on my y-axis. But I also know it moved down. So it's going to be a negative. So you could even have students create the pathway for their bot and then kind of challenge, okay, where's the bot located? Because obviously we know that ordered pair is to give a direct location. Another little hack that I wanted to share, this is Jen's hack, but I know many of you are familiar with Ozobot, and this has been a game changer for me. So I'm all about sharing knowledge. Knowledge is power. With any of your lessons, if a student makes a mistake, I'm going to jump back to this 3rd grade map really quick. If students make mistakes with their color codes, a great solution, I hate to tell you all to buy anything, so put it on a wish list. Christmas is coming. But you can get, for like $2, a bulk pack of just white shipping labels, and then you can cut them to size depending on what you need. So for example, if I was correcting this map and maybe I programmed an equivalent when it was supposed to be non-equivalent or whatever the case might be, you can utilize very easily without having to reprint or worry about additional copies, a shipping label, cut to size, cover that code right up, and then the students can use their markers to draw right on top. This has been a game changer for me as far as making maps and making tweaks and debugging. So that's a good little debugging hack for your students to use. All righty, Melissa, I think I'm back to you.
Yep. All right. That was wonderful. Thank you all for such a thorough overview of these lessons. They're so much fun. So just as a recap, if you're looking for these lessons, they can be found in our lesson library with the recording and the resources that we provide on our webinar page. We will have the slide deck up for you to access. And the links are here on this slide. If you need a recap on how to use these lessons, we have an Ozobot blog, which gives recommendations on how to deliver this content in in whatever educational setting your students and yourself are in. And then we also have a recap of all of our introduction to Ozobot lessons on this slide as well, the link to those recordings. With that, I'm going to pass it to Anthony to cover our student view and our one-to-one program.
Awesome. Yeah. So thanks to Jen, Natalie, Melissa for sharing those lessons. It was awesome. Natalie did a great job. I think Jen won it with that live demonstration of the that activity. So I will jump into our student view. Melissa started off showing the teacher view with what Ozobot Classroom looks like. So I'll give you a preview of what the student view looks like so you have an idea of what that is. It was designed thinking that students were in a remote type scenario, but it's usable either way. And I'm going to share, I'm going to request to share my screen. So in this case, this is my student account, and we have that Google Classroom integration that I mentioned. And they were assigned our Introduction to Ozobot Get to Know Evo, so they can open that from their email account. And this is within Google Classroom, which yeah, that's right, Google Classroom, which looks familiar. You can click through to that, or your student will be able to click through to that, and they would just simply sign in using their Google Classroom account. So now that we're in here, this is that student view where they log in, has a nice greeting, gives them an idea of how long the lesson or activity takes. Every time you kind of get started, we do want to make sure that Ozobots are up to date. So there'll be a little bit of a question about that, but we can skip that for now. And we kind of get started with objectives. So this is what they'll learn in that lesson activity. So in this case, they're going to identify and label the hardware components of Ozobot Evo. We'll upfront make sure that they have everything that they need. So you'll need an Ozobot Evo, pencil, crayons, and markers, and the activity sheet that's included. And then today we kind of went over in live perspective of like what those lessons activities look like. But within student view, I'm going to actually make this a little bit bigger so it's normal. These are the student-facing instructional videos that Melissa mentioned. So we do provide the full lesson plans where if you want to lead it, but these are also the videos that students can watch to support that. If you click the I, it provides a little bit more information on what's included. If they have questions or get stuck, they can click the link at the bottom. That'll take them back to Google Classroom to send a message and ask you a question about that. What students have, I guess another question I get a lot of times is, do they have to complete it all at once? They don't have to. They can kind of access these videos as needed. And then when they're ready to submit their lesson or activity, you can upload up to 3 photos. So I will upload a photo. And I actually did this activity, so I'll get that to upload. At some point. Awesome. And then if you want to have students add a comment or want to prompt them with something that's optional, but it is not required. And something that we heard a lot right now is social emotional well-being is super important right now. So we provide an option for students to provide cues for that. And in this case, I am very happy because I'm with you all today and got to show you the student view. So we'll submit that and it is all set. And once I've submitted that, that is submitted through to Google Classroom, to Ozobot Classroom, and you can access it wherever you are looking for that information. Hopefully I didn't talk too fast, but that is the student view. And can I pass it back to you for the screen, Melissa?
Yeah, sure. Let me get back on the correct slide and then get that up for you.
Awesome. Sorry, I was reading the chat or trying to catch up in the chat. So this is the one-to-one program. You got a preview of our math lessons as part of the program. Melissa talked about the intro lessons. Pretty much all of our Learn Anywhere lessons are accessible to as kind of getting started. So at least the onboarding lessons, ELA lesson and math lesson will be completely free and accessible. But at a certain point, we will be kind of gating those, and it'll be solely part of the one-to-one program. You can see the picture, but I also have my little student pack here. So that's what students get as far as the hardware side of things. You get an Evo robot, markers, charging cable, some activity sheets, and then you also get the hardware for in class, which is nice. So it's a nice solution to support quick transitions no matter what the school year brings. You get those remote-ready lessons. Plenty of PD opportunities within Ozobot Classroom, and then showed you a student view, but within teacher view, you'd be able to track all that engagement that I showed you. And that's everything at a very high level. If you have any questions, happy to go through that with you. Oh, sorry, got ahead of myself. Very common question is, how are schools going one-to-one with Ozobot? There's quite a few ways with using federal funds or state funds. The big one is the CARES Act. I know personally I've had a lot of schools come in through the 21st Century Schools funds, but quite a few initiatives. At least on all of our end, we try to stay familiar with state funds. So if you have any questions, we can help you kind of find solutions or creative solutions for that. So you can always book a demo with us, ozobot.com/hybrid. And we'd love to share more about the one-to-one program and how you can get it funded. And we'll jump into the Q&A. And I think Casey had some questions. I might have missed if they were answered in the moment, but there was one about what does calibration do, and if they need to calibrate every time.
Shoot, I forgot my book. I need my book.
Oh,
just come up with words.
So yeah, did you want to talk about calibration, Anthony, or would you like me to? What would you prefer?
I'll do my basic response, and if you want to elaborate on that. So Evo has little optical sensors on the bottom of the robot, and that's how it's able to read the different color codes. And just depending on lighting in the room, it'll read white and black and the different colors differently. So you want to calibrate Evo to that black dot so it knows true black and true white and can work with the color codes. Typically, you only need to do it that first time, assuming the room's lighting doesn't change at all.
Yes, and just to add on to that, if your students do run into any issues during the lesson, we always do recommend that the first attempt at debugging is to calibrate calibrate the bot, because if they forget in the beginning or if the lighting conditions change, then it'll affect the behavior of the bot. So that's just something to keep in mind if your students run into any issues or trouble with it. Cool. And then the next question is there a version without remainders for the division race lesson? We actually have a couple of different division lessons that are scaffolded. So we start with division race, which is what Jen showed you today, with no remainders. Then we have division race with remainders, where it's very similar, but there is a remainder component where students have to solve for that. And then we also have a division maze where students are solving for division problems, and the answers actually correspond with specific color codes that they're coloring in. Jen, do you have any other comments that you wanted to chime in?
Division maze is more of a fact practice type of thing. There's two different mazes in that one. One covers divisors 1 through 5, and the second one covers divisors 6 through 9. Or 6 through 10, 6 through 9, I think is what I put in there. So they may want to start with a division maze and just do their fact practice first, and then move to division race, and then division race with remainders as you progress through your division unit. So.
Great, thanks. And we actually have a question from Sharon in the audience asking how the races can be modified for students with IEPs and, or special in special education. Do you have any suggestions for students that may have special needs?
Are we talking about the division ones in particular, or
I believe so,
or
yes.
other lessons?
The division race lesson.
The division race ones.
Yes.
You know, you can leave the color code out so that the bot will just do its regular speed, but for a student who may be struggling with division, I would put in the slow code, and then maybe even have somebody walk them through. You could also have a division, like a key of math facts next to them so that they can use their math facts sheet as they're going through the problem. I mean, you really could use that sheet without the Ozobot if you wanted. You could have them fill in the numbers first and then have them run their bot as they check the problems. You can have them work together if you're in a situation where two students can work together. You can have one student be asking the questions and the other student writing the answers to the problem. Yeah, but just off the top of my head, those are a few things you can do. You could also change the problems so they're easier. You don't have to use the problems that come with the lesson. You could make it so that, for example, the first example we did was 34, and 3 divided by 2 doesn't work out evenly. So you could change the problem so that each part of that came out evenly, instead of when you subtracted, there was a number left over. Those are a few ideas.
Even using the track, Jen, you got me thinking, using just the track and having kids practice other math fact problems would be a really great way to scaffold it for students who maybe are not yet ready for division or the rigor of these division problems that we've provided. Yeah,
that's what I was going to suggest, that you could use the pathway, use the map, but have them solve other math problems, and that way they'd still be racing their bot in a way that's meaningful for them, that they can hopefully succeed at.
Great. We have another question. Sounds like a couple of our educators in the audience have a lot of students. Looks like 290 and over 400. And they were asking, what is the best way to get them all loaded for an account? And that's Sharon and Rhonda in particular. Are you talking about a Ozobot Classroom student account? Is that what you are referring to? If you could clarify in the chat, that would be helpful for us to better help you. But if you
also unmuted everyone, so if
oh,
they
great, thank you.
By unmuting, that would work too.
Okay, this is Sharon. This is Sharon, and I think what I'm using is Ozobot Classroom.
Okay. And you are, do you have Google Classroom with your district or with your students?
No, I'm sorry, I don't. We just started to use Microsoft Teams.
I see. Okay, so what we would recommend, if you are not a Google Classroom user, we actually recommend when you find a lesson that you want to share with your students and have them do. Right now, our engineering team is still building out other LMS integrations. We're only compatible with Google Classroom for right now, but we're building for others. What we actually recommend is that when you go into the lesson plan, there's this instructional video component. So you can print the pages. If you go down to the bottom, you'll see that you have student, these are the student activity guide. So you could print this for your students if you wanted to. Again, this isn't necessary. All of this is covered in the video. We just provided this as a resource if you needed it. And then these are the student worksheets. So you would just have to print the worksheets for your students or have them print depending on what your situation is. And then somehow through your LMS system, you can share one of these video links. I've included all either this playlist where students can kind of self-pace and self-guide by going through every single chapter themselves, or every lesson also has a full-length video. Let me pull that up so you can see what that looks like. That will take you to a full-length video where they can just play the whole thing straight through without having to go chapter by chapter. So this is what we recommend for the moment while we are adding more learning LMSs. And if that didn't answer your question, please feel free to clarify.
No, I think that was helpful. Thanks.
Okay, great. Yeah, we're so glad you asked. Are there any other questions? Okay, great. Then we will move on to our giveaway. And since Anthony is our special guest host today, Anthony, if you could do the honors of choosing a number between 2 and 37 to announce our winner. Just for those of you in the audience, just so you know, when you entered that, entered your information into that Google form, it populated into a spreadsheet, and the number that Anthony chooses will correspond to a name based on the order that you all filled out and submitted your information. So,
so we'll do drum roll 33. Hopefully somebody's gonna like me.
33.
33 is Laura Gilly.
Congrats.
Congratulations. So if you could email Cassandra at ozobot.com, she will get your educator entry kit to you. Congratulations. Just to wrap up very quickly, if you are looking for a PD certificate, please email support@ozobot.com. If you'd like a recording of this webinar when it's available, you can opt in for updates at ozobot.com. If you scroll to the bottom of the page, there's a field for you to enter your email address. And then again, we have our links to all of the lessons we shared with you today. And there's a link here for you to learn more about going one-to-one with Ozobot. And with that, I hope everyone has a wonderful evening. Stay safe and healthy out there. It is almost Thanksgiving, if you can believe it. So just to let you know, tomorrow evening we are hosting another webinar. Jen has created a wonderful gratitude lesson that we would love to share with all of you. And hopefully your kids can participate and use our Ozobot gratitude lesson. So feel free to tune in tomorrow. And we will see you soon, hopefully. Have a great evening, everyone.
Have a good night. Bye.